Welcome back to Cleantech Conversations, where we talk to the people shaping the technologies and industries for the net zero future. Today's guest truly needs no introduction, but deserves one anyway. Professor Martin Green from the University of New South Wales is a legend in the world of photovoltaics. Often referred to as the father of modern solar cells, his research defined entire generations of cell technologies. From the early days of crystalline silicon to the PERC cells and beyond. In this episode, we talk about what's next in the solar innovation, what it takes to bring lab breakthroughs into reality, and what role Europe and other regions can still play in a world dominated by Asian production. So let's dive in.
Thank you very much, Sebastian.
Martin, you've been at the forefront of every major solar cell breakthrough for decades, right? We're talking from PERC, TOPCon, IBC, now even heterojunction, tandem. From your perspective, which technologies are truly ready for large-scale industrialization, and which ones still need or have manufacturing hurdles?
Yes, well, I guess the history of the industry has been moving to more and more efficient solar technology. So, like starting with the transition to PERC and then rapidly to TOPCon. I think the next transition will be to IBC, back contact cells. But of course, I think tandems are the ultimate photovoltaic technology where there's still a lot of challenges, but I think that's the way the industry has to progress. So, perovskites have shown great performance in the lab, and maybe they can be developed so that they're stable enough for market introduction. But if perovskites don't work, we've got to find other material that can be used in tandems.
Interesting. So you're saying TOPCon now, IBC, and ultimately tandem devices. So scaling new cell architecture is always an issue, right? So you, as an equipment supplier, we're looking always, you get great efficiency results in lab, and you did this fantastic couple of decades even ago, but it's still a way to bring this to reality, to really yes. To mass production, right? What do you see as a generic view as the most underestimated challenging when you talk about scaling next-gen solar cells?
Yeah, I guess from our perspective, we were always told that what we were working on was too complex to ever be used by industry. So when we started working on PERC cells, everyone said, you're wasting your time. Industry's never going to be able to manufacture something that complex. So it's really been quite encouraging the way that industry has shown it can master increasingly complex technology. So I've got no doubt, regardless of the complexity of the processing required, that industry will find a way of making something cheaply. So that's why I'm quite confident that we'll see the industry progress to back contact cells despite the extra complexity. So I expect 5 years' time at this exhibition, everyone will have IBC modules, and we'll see an increasing number of tandem modules with the perovskites, but whether they'll really have made an impact on the market or not is still an open question, I think.
Let's see. We are meeting here on the occasion of the Intersolar Europe, right? So given the current dominance of China in the manufacturing side, right, do you still see a meaningful industrial role for Europe and maybe also the United States in the next wave of PV innovation? And if so, where should it begin, the role of Europe maybe?
Yeah, no, it's quite a difficult question, and I often think about this in the Australian context as well. But the Chinese industry has proved itself very efficient at adopting and developing new technology. So it's very difficult to see how other countries can keep up with the progress there now that they've got a critical mass of not only the manufacturers of the cells themselves, but the suppliers of everything that's needed in that manufacturing process. The China industrial scene is probably a little bit different. Well, it's a lot different from the Australian scene in that there's a lot of transfer of knowledge between companies. So it's more like a consortium approach to the manufacturing that happens in China. Not deliberately, but just through the rapid transfer of staff between companies, and I guess the equipment suppliers are a big factor in helping with technology transfer as well. But one of my colleagues, Pierre Verlinden, described it, like a beehive, the Chinese industry, like everyone was sort of beavering away at their own thing, but the whole knowledge was getting put into a pool that everyone could access. Mm-hmm. So, it's a little bit different, in Australia. Traditionally, with the solar cell manufacturing, when there was some in Australia, the companies would keep all the information very close to their chest, and there was company secrets, and no one knew what the companies were doing. But in China, the information becomes generally available quite quickly. So that part of the system there is probably unique, and I think it contributes to the rapid adoption and development of technology. So it's hard to see that being duplicated in other countries.
So maybe looking beyond cell physics, how do you see the way of digitalization? You talked about information sharing. This is also done in China on a digital way, but now we talk about digitalization and AI in the factoring process. Do you see here an influence on the next generation of solar cells and in the next generation of manufacturing, right? Or is it even taking place? So what is your take on this digitalization and AI in the meaning of PV production?
Yeah, I think it'll have a big impact in manufacturing. Like, we were involved with the establishment of the first commercial manufacturing in China through Suntech, and from Australia we used to look at all the production data and so on, and look for trends and that kind of thing. But I imagine AI could do a much better job than we ever did. So we'd have a look at it, and someone would have a brainwave about how things could be made more consistent. But I'm sure with AI you'd be able to look at that in much closer detail and get everything sort of optimized, to the maximum extent that's possible. So that that's one area I can see AI having a big impact. And then in the research field, like as I mentioned, I think a tandem cell is the ultimate photovoltaic technology. Probably thin films. So my theory is, you've got to put a tandem on silicon first, because then you get the big manufacturers involved. They can introduce as a premium product or something like that, take advantage of their market strength and so on too. And if the product doesn't prove reliable or something, they've got the resources to patch things up. So I think the first tandems that go commercial will be tandems on silicon. Mm-hmm. And to put one tandem on silicon, you've got to change the technology, which probably to the benefit of companies like Van Ardenne, you're going to need transparent conductors and so on, which are not I guess a normal part of silicon production, apart from heterojunctions, of course. So you've got to sort of change the technology a bit to put one cell on, but the second cell you don't have to do too much different from one cell. So putting two cells on silicon sort of makes sense once you mastered putting one cell on. But then the contribution of silicon to the final output gets reduced by the number of cells in the stack. So the silicon's only contributing a third to the power output. Mm-hmm. So like a 24% silicon cell will only be contributing 8% to the total power. Mm-hmm. So you then ask the question, you'll have these other thin film technologies that are stacked onto silicon, validated with a lot of field experience and terawatts of production. You'll say, is silicon needed? So my theory is we'll go to 2-cell tandem on silicon, and then we'll go to a 4-cell thin film stack as the as the next generation of technology. Ultimately, maybe to a 6 or 8-cell stack. The manufacturers here, like promoting these incremental improvements that are being made in efficiency. So like even though diminishing returns on adding more cells to the stack, there might be the incentive just to get the edge over their competitors by adding one more. So we might
Very interesting.
We might see cells with 8 or 10 cells in the stack, even though the last 4 or 5 don't add too much to the performance.
So it's kind of a rebirth of the thin film PV, right? So that you combine now thin film with crystalline, and maybe at the ultimate you're staying on multiple thin film devices.
Yeah,
interesting.
That's my prognosis. So, the important thing is finding a material that has all the attributes that silicon has, which is stability and non-toxicity, abundance, and so on. And
there I understand that AI plays a role, right? Because it's a big bunch of materials, big bunch of chemical deposition methods, deposition conditions, let's say.
Yes.
And you think that AI can contribute to this?
I think so. It might be able to find a path through it. Particularly as software for analysing cell materials and so on gets better and better, which it will. Combined with AI getting better and better, there'll be an ability to search through the available materials much more thoroughly than people have done so far, and perhaps find a magic material there that works as well as perovskite but doesn't contain lead and is as stable as silicon. So that's what we need.
Very interesting view. So I'm interested also in the role of the, let's say, research industry and the partnerships with each other or maybe with the companies. So you're running UNSW and institutes since decades. So what is, in your experience, make the difference between a, let's say, successful lab to fab transition and a project where it gets stuck in a kind of valley of death? So what is important for these next generation devices that they avoid this?
Yeah. So the IP seems to play a role. Like PERC got commercialized when all the IP had expired. So the way the industry has evolved, and it's so strong now, I think, in that everyone's doing pretty much the same technology. So so the whole supply chain can focus in on what the standard approach needs. So at this exhibit, like most of the modules at TOPCon, and the equipment suppliers can focus in on what TOPCon manufacturers need, and can work hard because they're not just supplying one manufacturer, they're supplying dozens of manufacturers with their equipment. So that's been an important part of the industry, has been conformity to a standard technology. So the industry switched very quickly from the established technology to PERC. It only took 3 years to make a complete transition, and the same will happen with TOPCon. So it's but I think that's been an important factor in getting the costs of solar so low. And now we're getting a lot of litigation on TOPCon. Some of it seems a little bit frivolous, but like we made our first TOPCon cell in 1981, so the technology goes back a long way. So not having intellectual property barriers, I think, has been important to commercialization of new technology, because the whole industry has to transition to it. An Australian, Cadell Evans, won the Tour de France 5 years ago, I guess, but maybe a bit longer. But so I used to talk about the peloton and the breakaway a lot. So in cycling, the breakaway can hang on and make it to the finishing line. The peloton sort of tries hard to catch but just misses out. But in solar, there's no real finishing line. So the breakaway is going to get caught by the peloton, to my mind. So having this consorted effort and having a uniform technology, I think, is important to continually reducing costs.
Very interesting. So maybe I have one final, more personal question. So you've been called like the father of the modern photovoltaics, right? So looking back, what gives you the most hope about where we're heading with PV in the next decades? So what is your big picture on PV on a global stage?
Yeah, the costs are very low now, and like I've been accused of being overly optimistic in the predictions I've made in the past, but I was far too conservative. The actuality has happened a lot more quickly than even someone naturally optimistic like myself has been able to predict. So where it costs now that were just unimaginable, even 10 years ago, I think. So the costs are there. The world is sort of waking up to the potential of solar. The other good thing that's happening is battery costs are coming down very rapidly as well. So in Australia now, we were very heavily dependent on coal for our electricity production, but the coal plants are closing a lot more quickly than anticipated. And then when they close down, they use the site for battery storage because they can use all the transmission and everything that was there for the coal plant. So it's generally not the same capacity as a coal plant, but some reasonable fraction of the coal plant capacity gets installed at the former coal plant site. So as batteries become cheaper, that'll become a more common model, I think. You know, I was talking to someone yesterday, and they sort of could see the possibility of a surge in solar uptake happening over the next few years. So rather, a lot of people are predicting things are going to stabilise at present levels, but you know, I think myself with equal probability that there'll be a big surge now that solar is, you know, the cheapest way of generating electricity, you know, even when combined with the extra cost of storage.
So we are just at the beginning of a revolution, right, for renewable energy to deploy that on a global stage, right?
Yeah, that's what I hope happens, because, you know, we urgently need it. The climate is changing very quickly, and you know, it's probably better that it didn't. So I hope that the solar can fulfill its full potential very quickly. So I think in Australia it'll happen. Like, I think solar will be the main source of our electricity, you know, within a decade, transitioning from a system that was completely dependent on coal in the past.
Very interesting, yeah. So let's meet in 5 years, 10 years and see where PV is, technology-wise and commercial-wise and price-wise. So I'm very thankful for you being here, and thanks for the conversation.
Yeah, good talking to you, Sebastian.